So the concept is the DMA controller. Okay. So here the direct memory access. So the main purpose of the DMA controller is to transfer the high speed data in between the memory and the peripherals. So the what is the importance of DMA controller? The importance of the DMA controller is to transfer the high speed data transmission between the memory and the peripheral devices. And for this, it will not take any support from the processor. So as you see on the slide clearly, DMA controller transfer the block of data between the memory and the peripherals and without the participation of the processor. But the important thing is, so if you want to perform any operation with the microprocessor, so or any CPU, whether if you want to send the data or whether you want to receive the data, whatever operation you want to perform, without the support from the processor, we cannot do anything. But how the DMA controller is transferring the data between the memory and the peripheral. So what is the importance of this controller? So I am going to cover that. Okay, the 2 marks question you can expect from this concept is the first one. What is the use of DMA controller? So the DMA controller is mainly used for transferring the or performing the high speed data transmission between the memory and the peripherals. Are you clear?
Yes, sir. Yes.
Okay, so how it will do? So I have the simple diagram to explain this concept. So the diagram consists of 4 typical units. First one is the microprocessor, and second one is the memory, and the next one is the IO device, and our main topic DMA controller. Okay, so here are you able to see the 3 dark lines for each and every unit? MP to memory and the IO to DMA and DMA controller to MP and the memory in between. Are you able to see those black
Yes,
starlight?
sir.
Yeah.
Yes, sir.
What
Yes,
are
sir.
these
sir.
Yes,
lines?
sir.
So these lines are data bus, address bus, and control bus. Okay. So these lines are
Okay.
used for representing the 3 buses which the processor will use for performing the data transmission or any operation. Data, address, and control bus. Okay. So here we are making use of 3 data bus, address bus, and control bus. And the microprocessor is the main key role it will perform, okay, for transferring any of the data. But I am taking DMA controller to perform the data transmission. So how it will do? If any IO device wants to transfer the data, okay, try to understand the concept. If any IO device is requesting the DMA controller, like I want to transfer the data continuously from the memory to the device, it will ask the DMA controller. Then the DMA controller will send the request to the microprocessor. So what is that request? That request we are calling it as a BR. BR means bus request. Okay, to transfer single bit of data also we need to take permission from the processor. If a processor gives the permission, then only we can transfer the data, or else we cannot transfer the data. So the whenever the IO device requested the DMA controller, it will send one request to the microprocessor. What request it is sending?
For the data transfer.
What request it is sending for data transfer?
BR, bus request. Bus
Bus
request.
request, sir.
Yes, it is going to send the bus request command to the microprocessor. Once it receives the bus request command, wait a minute. Okay, are you able to see the screen, right?
Yes, sir.
Okay, once it receives the bus request command, if the processor is ready to accept the data transmission, okay, if the processor is ready to accept the data transmission, it will send the acknowledgement, hold acknowledgement we can call it as. So it will send the hold acknowledgement with the help of bus grant. Grant means permit. Okay, so whenever the IO device is requesting the DMA controller, I want to perform high speed data transmission, the DMA controller is sending request to the processor saying that I need all the buses, okay, to transfer the data. So if the processor is accepting it, then it is telling, okay, you take the control over the buses by issuing the signal bus grant. Are you clear? So if IO device
Yes,
is
sir.
requesting DMA, it is taking permission from whom?
Processor.
Microprocessor. Processor. By issuing what signal? Bus request. How it is telling microprocessor? By issuing the bus grant, it is telling, okay, you can take the control over the buses. Now what will happen in the background? So whenever the microprocessor is issuing bus grant, the microprocessor will completely lose control over the buses. Okay, so all the buses are under control of the DMA. Now the processor cannot do anything. That's what I am telling. Without intervention of the processor, DMA controller is transferring. Are you clear?
Yes, sir.
Yes, sir.
Now the bus grant is done, then it will take control over the memory and IO devices so that it can perform the high-speed data transmission between the memory and the IO device. Are you clear so far?
Yes, sir. Yes, sir.
In the block diagram of DMA controller, so I can say the technical terms, the hold and hold acknowledgement. Hold is equivalent to bus request and hold acknowledgement is equivalent to bus grant. So acknowledgement means what? So you are telling, okay, you take it. So that is an acknowledgement. So bus request, bus grant are equivalent to hold and hold acknowledgement. You have to remember this. Again, I will ask you. Fine. So bus request is equivalent to what?
Hold
Hold.
and hold.
Bus grant is equivalent to?
Hold acknowledgement.
Yeah. Now, so if you want to make, actually this DMA controller is designed by the Intel. So the Intel 4-channel DMA controller, we can call it as. So it's an Intel 4-channel DMA controller. And each and every channel is capable of sending 128 bytes of data. Okay. So each and every channel, we can call it as Intel's 4-channel DMA controller. Fine. And it is a 40-pin DIP. That means it is having 40 pins. Okay. And it is having totally 8 blocks. Fine.
Okay, sir.
If you want to transfer the data in a DMA controller, so we can make use of 3 modes. And this is a 2 marks question. What are the different modes the DMA controller will use to transfer the data? Enlist the different modes of data transfer in DMA controller. So the modes are 3: burst mode, cycle stealing mode, and the transparent mode. I repeat, first one is the burst mode, second one is the cycle stealing mode, and third one is the transparent mode. Fine.
Yes, sir.
Okay.
Yes,
So the
sir.
burst mode, what is this burst mode? So the burst mode is like if you want to transfer the data between what it is transferring the data? DMA?
Memory and peripheral devices.
Yeah, it is transferring data between the peripheral devices.
Yes, sir.
Okay. So here, if you want to transfer the data in the form of burst mode, okay, so the microprocessor will completely releases the buses, okay, and it will give control to the DMA controller, and it will not interrupt the DMA controller until and unless it finishes the data transmission. Are you clear?
Yes, sir.
Yes, sir.
Yes, sir.
The simple thing is microprocessor will give the DMA controller will take control over the buses, and once the controller is given by the processor and it will not disturb any DMA controller, again whenever the data transmission is finished, then only the processor can get the control over the buses. So this mode is called the burst mode. Okay, and the next one is called as a cycle stealing mode. So what is this cycle stealing mode? The simple thing, first the DMA controller will have one clock cycle and the microprocessor will have one clock cycle. Okay, so 2 clock cycles we are using. DMA controller is one and microprocessor is one. So in this process, alternatively they will transfer the data. I will explain how alternatively means. First byte the processor will transfer and the second byte the DMA controller will transfer. Again the turn goes to processor 1 byte and DMA controller will take 1 byte. And in the same way this will keep on going in a loop. So cycle. So it will transfer first, next the DMA controller will transfer, and next the processor will transfer, and next the DMA controller will transfer. Are you getting?
Yes, sir.
Yes, sir. Yes,
So
sir.
one by one, why I am calling it as a cycle stealing mode means it is taking off part from the processor cycle. Okay, it is taking off part from the alternative cycles from the microprocessor. So that's what we are calling it as a cycle stealing. It is stealing the cycle of the microprocessor, data transmission cycle of the microprocessor. That's what we are calling it as a cycle stealing mode. Okay, so this is one type of mode. Burst mode, what it is doing? Completely it is taking control over the buses and it is sending the data. Are you clear with that?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
And in cycle stealing mode, what it is doing? Alternatively, it is transferring the data, and we are calling it as a cycle stealing. Are you clear with this?
Yes, sir. Yes, sir.
And the next one is, what is the next one?
Transparent mode.
Yeah, transparent mode. The next one is the transparent mode. So in the transparent mode, what it will do? So the DMA controller take charge on the system bus only if the processor does not have system bus. That means the processor is free. Okay, if the processor is free and it is not performing any work with the buses, in that case only the DMA controller will take control over the buses and it will transfer the data. So it is a clear. So the processor is free, it is giving control. That kind of mode will be called as a transparent mode. First mode, if it gets the permission until and unless it finishes, it will not give the permission. What we are calling it as?
Burst modes.
And second mode, simultaneously, like alternatively, processor and the DMA controller is transferring the data. What we are calling it as?
Cycle stealing.
Yeah. And in third mode, whenever the processor is free, it will take control over the buses. And this mode we are calling it as a
Transparent.
transparent mode. So are you clear with this? What are the three typical modes we are going to use in the DMA controller?
Yes, sir. Yes, sir.
So burst mode, cycle stealing, and the transparent mode. So this one you can expect for the 2 marks. Okay. And
Yes, sir. Yes.
so the one which you saw previously is a simple unit of the DMA controller, and now this is the in detail version of the DMA controller. Are you able to see the screen?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
We have 4 major units. What are they? What are they?
Processor, memory, DMA controller, IO devices.
IO devices. Okay. Now I can explain you clearly about this. Are you able to see the IO device and what are the things we have attached to the IO device?
Yes, sir.
3 signals are there: DACK and DRQ and IO write and read. Okay. First I will tell you IO device. If the IO device is requesting DMA controller DRQ by issuing the signal, and simultaneously the DMA controller will send the signal to the processor. Hold means what?
Hold means bus request, sir.
Processor, it is requesting you give me the control over all the buses, it is telling the DMA controller. If the processor is okay, what it is issuing?
Bus grant.
Bus grant.
Bus grant. So here we don't have bus grant, we have hold acknowledgement, HLDA. Isn't it? So the hold acknowledgement will be issued to the DMA controller. Once the hold acknowledgement signal is issued to the DMA controller, so the IO device, the DMA controller should tell, isn't it? You can transfer the data. It should tell the IO device also, I got the permission from the processor, so you can transfer the data. So to indicating that, it will issue the DACK. That means DMA acknowledgement. Are you clear?
Yes, sir.
Yes.
It will issue the DMA. Then the IO device will understand, I got the permission from the DMA controller to transfer the data. So it will perform the data transmission in between what? Our main hero role is
Memory
what?
and peripheral.
Memory and the peripherals. Now this processor will be idle. It will not do anything. And this will be activated. Memory and IO device will be activated. And the DMA controller will performing bidirectional memory read and write from the memory and IO read and write for the IO devices. Okay. So then MRW and IOWR will be activated. Are you clear? So IO, memory read and IO device. So in between memory and IO device, it will transfer the data. So that data with the help of memory read and write and IO read and write. Are you clear?
Yes, sir.
Yes, sir.
So this is the working principle of the DMA controller. So the main motto of the DMA controller is to perform the high-speed data transmission between the memory and the peripheral devices. It is just like our mobile phones are there. Like we are making use of the different cables for performing high-speed data transmission. Okay, 3.0, 4.0, 2.0, we will tell how it will achieve. So if the processor is into the picture, it cannot do that high-speed data transmission. So if we keep processor aside for few minutes, and then we can perform the high-speed data transmission. And the major role of the DMA controller is that only, high speed. Sometimes it is not possible for us to continue with the slow speed data transmission. Even you people also will not accept if the data transmission rate is very low. Will you accept it?
No, sir. No, sir.
So to achieve that, we are making use of the typical unit, one more sovereign unit. We are calling it as a DMA controller. Fine. Hopefully, everyone understood this.
Yes, sir. We understand.
Okay. Then I'm going to the simple block diagram of the DMA controller, what it is actually having. So the DMA controller is mainly having, it's a simple block diagram, DMA block diagram, simple. So it is having basically three register, word register and the data register, and count register also you will have, word count and the data register, and the starting address and the control logic. Okay. So you need to draw like this only, it's a simple block diagram. After this slide, I'll explain the typical block diagram of DMA. So the word register, the basic word count register is mainly used for counting number of words transferred between the memory and the IO. Okay, what it is? What it will be used for? Counting the number of
Words transferred
Word.
from memory to
the peripherals. Okay,
peripherals.
and the data register. The data register is responsible for storing the data which it is going to transfer. Either 10 blocks, 5 blocks, 20 blocks, how many blocks of data it will transfer. So that will be stored in the data register. And the starting address, from where it is going to start the data transmission process. Okay, and it will get those lines from the processor. Okay, it will get address lines, all the address lines which we are using. So starting address of this memory address lines will be stored. For example, I can say 20 address lines I am taking. From the 20 address lines I am transferring the data. So the starting address will be indicated by some 0000 and ending address will be indicated by 0020. So starting and ending, in between those, it will transfer the data. And the control unit is mainly responsible for taking the permission from everyone. Like IO is there. So IO is issuing what bus request it is asking. Okay. And the DMA controller is again asking processor hold, and it is telling hold acknowledgement. Once it is done, then it is giving DMA acknowledgement, and it is performing read and write operation. So all this synchronization part will be under control of the controller. Are you clear?
Yes, sir. Yes, sir.
Is there anything confusing?
No, sir.
Clear, right? So the word count register is simply for counting the number of words transferred, and data register is actually what we are transferring, and the start address is from where we are going to start the data transmission, and end address also it will have. And these all things will be connected to the data bus of the microprocessor, and address lines will be connected to the address bus. Okay. And next, the control logic is having read and write operations it can perform, and the DMA request and DMA acknowledgement, and the interrupts. Interrupts are nothing but bus request and the bus grant we can call. Bus request and the bus grant are IO read and write and the DACK. Those everything will be considered as a interrupts. Okay, because it is interrupting the microprocessor. What is interrupt?
To hold the data transmission.
So interrupt is like simply when the microprocessor is executing any program, if you try to disturb the microprocessor, okay, then that thing will be called as an interrupt. So is the DMA controller is interrupting microprocessor?
No, sir.
Yes, sir. Yes, sir. Yes, sir.
Obviously the microprocessor, like the DMA controller is interrupting the microprocessor. Why? Because we don't know when the IO device will ask